Welcome. I'm Dr. Jan Carney, Professor of Medicine, Associate Dean at the Larner College of Medicine. I'd like to welcome you here to the Dan and Carol Burack President's Distinguished Lecture Series. The goal of the Burack Distinguished Lecture Series is to bring to our campus distinguished guest speakers who enhance our academic experience, showcase our faculty and programs, and draw groups of faculty and students together on a regular basis. UVM alumnus Dan Burack, class of '55, and his wife Carol, designated a generous gift to the campaign for the University of Vermont to endow the lecture series and support undergraduate scholarships. The university named the President's Distinguished Lecture Series in the Burack's honor to recognize their philanthropy. Since 2003, the Burack Distinguished Lecture Series has brought over 125 lecturers to the University of Vermont. I am delighted this evening to introduce Dr. Jeffery who will be presenting this evening's lecture entitled, Do New Tools Need New Ethics? The Challenge of Advancing Biotechnology for Ethics and Policy. I'd like to tell you just a little bit about Dr. Kahn. He received a BA from the University of California, Los Angeles, his PhD from Georgetown University, and his MPH from the Johns Hopkins Bloomberg School of Public Health. He is the Andreas C. Dracopoulos, Director of the Johns Hopkins Berman Institute of Bioethics, a position he assumed in July 2016. From 2011, he has been the inaugural Robert Henry Levi and Ridna Hecht Levi Professor of Bioethics and Public Policy. He is also professor in the Department of Health Policy and Management of the Johns Hopkins Bloomberg School of Public Health. He works in a variety of areas of bioethics, exploring the intersection of ethics and health science policy, including human and animal research, ethics, public health, and ethical issues in emerging biomedical technology. Professor Kahn has served on numerous state and federal advisory panels. He is currently chair of the National Academy of Sciences, Engineering, and Medicine's Board on Health Sciences Policy. He also formerly served as a member of the National Institutes of Health Recombinant DNA Advisory Committee. In addition to committee leadership and membership, Professor Kahn is an elected member of the National Academy of Medicine as an elected fellow of the Hastings Center. He is a co-principal investigator on genomic users in infectious disease and epidemics, an NIH-funded project to study the large, unexplored ethical, legal, and social implications of genomics as applied to infectious disease. Professor Kahn's publications include Contemporary Issues in Bioethics, Beyond Consent, Seeking Justice in Research, and Ethics of Research with Human Subjects, Selected Policies and Resources, as well as over 125 scholarly and research articles. Please join me in welcoming Dr. Jeffery Kahn.
Thank you. Thank you for that kind introduction, and I should say thank you to the to the Buracks for your generosity and the ability to be here, and to President Tom and Leslie Sullivan. Wonderful to see old friends. I should say Tom and I were colleagues at the University of Minnesota, where I spent 15 formative years, and where my wife Orly, who's here today, and I raised our two children. Really important time in our lives. So I'm really pleased to be here tonight. I'm going to wander a little bit, and you're kind of you could move down if you want to be closer. I'm also willing to talk as we go. I have about 45 minutes worth of slides, I think, but we can take that hour and divide it however you like. So I'm going to talk about some of the advances in science and some of the places we have been in terms of the oversight of the advances in science, and try to make an argument for you that we need to be quickly thinking about some new approaches. So let's see if I can make this work. I'm going to resort to manual. So the early part of this talk is really about what we have tried to do in the course of the history around regulating controversial and what were at the time new areas of science. And the story that people in my world like to tell is about the beginnings of the Recombinant Dna Revolution, which was really launched by American and British scientists together. This is the report of the famous, in my world, famous Asilomar Conference. How many of you in the audience know what I mean if I say the Asilomar Conference? A small handful of you. So in the world in which I run, this is a really important and landmark story. As you can see from the title of this particular screenshot, which is from the article published in Science in June of 1975, report on the conference related to recombinant DNA molecules. And it was really about how the scientific community of that time proposed to regulate itself in terms of responsible use of what was this very new and, in their minds, controversial technology. What would happen if genetically modified organisms got into the water system, sewage system? What would happen if they created an organism that they didn't understand the implications of? And so, led by the scientists whose names are on that slide, they proposed to restrict what they would do in very particular ways. So part of that of trying to be responsible, and partly I would argue, and I think the history bears this, trying to make sure that the government didn't over-regulate the science they were proposing to do. It was a sort of way of inoculating themselves from stronger regulation. Didn't really work terribly well that in terms of the government not regulating them. And so I will show you now a little bit of a screenshot from the current, subsequent to this meeting, and all the way through the current day, regulations from something called the Recombinant DNA Advisory Committee, which is a committee of the National Institutes of Health, but the regulations that govern the use of recombinant DNA when they're applied to humans. And here's the highlighted part. As it says there in the yellow, the NIH will not at present entertain proposals for germline alterations. So the sort of most important aspect of the restrictions, really, and I would argue prohibitions on the use of genetic modification and the science that allows scientists to do that is that we won't do certain things and haven't been able to since the 1970s. The main and most important of them being this: we will not permit modifications of humans in ways that those modifications can be passed on to their offspring, so-called germline modification. So the government came in to regulate something that the scientific community had hoped to regulate itself, so not terribly successful. There are other versions of regulations that have come into being in terms of limitations on what can be done in the area of advancing science, which sometimes have nothing to do with what we think is right or wrong or responsible or not responsible, but rather have to do with the limit of technology. And that has to do, in the case I'm going to talk about for a few seconds, is something called the 14-day rule. So it turns out in science that takes human embryos outside of the human body, so mixes egg and sperm together, human egg and human sperm together, to create in vitro embryos. Think of in vitro fertilization or IVF as that example. They're only permitted to be grown outside of the body in a petri dish up to 14 days, no longer. So that was really a limit that had to do with how long human embryos would grow outside of the human body in a petri dish. It just couldn't be grown any longer. But it also has to do with what happens after 14 days. So here, this is a cartoon, of course, that shows what happens between 5 and 6 days and 11 to 14. You start to get differentiation of the tissues in a way that people thought, well, that's the beginning of what looks like a human organism. And so 14 days really should be the stopping point. And it turns out it's not possible, or hasn't been possible till quite recently, to grow a human embryo in a petri dish in vitro past 14 days. So it's very convenient. The technological limit kind of matched up with what seemed to be the right place to draw the moral boundary, the ethics line. So fast forward to really now, that's 2016, and there's something I'm going to show you momentarily that's even more recent, where a group argued in Nature that the 14-day rule needed to be revisited. And that's because they were able to allow an embryo to grow past 14 days in vitro. So you'll learn something more by allowing that to happen. And so the technological barrier had been breached. We can grow them longer in vitro, so let's revisit this limitation. So what's the ethics question? And even more recently, whoops, there was another slide there. All right, even more recently, there has been success in effectively jumping over, that's what the next slide is actually, jumping over stages of development such that something called an embryoid, so George Church at Harvard Medical School, MIT, Broad, that combination, has shown that he can use genetic techniques, genetic technologies to effectively grow an embryo for 14 days, but have a much later developmental stage, so sort of jumping over stages of development. So by leaving something in a petri dish for 14 days, he could really get something that looks more like a 28-day embryo. This is in an animal model, but the argument is he could do the same thing in humans. So 14 days doesn't really mean anything. It's the stages of development and the characteristics of that developing embryo that matter, and we need to talk about what those are in order to draw the line at the right place. So we don't have the right policy in place, is the argument. As science advances, the technological barrier no longer provides a sort of good stopping point for the ethics determination. I'm going to tell you a very quick story about when all the ethics arguments and the policies that have been put in place get sort of subverted by people who are very ingenious and have good reason to want to be so ingenious and resourceful. So that's a photo of a early stage embryo. That's an 8-cell stage, and that takes place 2 or 3 days after fertilization. So think about what happens when an egg, this is a human egg, is fertilized by human sperm. It's a single cell fertilized that then divides first into 2, then to 4, then to 8. So that's 3 divisions after fertilization. That's a pipette on the left holding the embryo in place, and that's another pipette on the right that has been put up to a nick that had been created in the wall of that embryo by a laser, and a single cell has been sucked out. That's an aspiration, a biopsy of the cell from that embryo. It's called pre-implantation genetic diagnosis, and you can then do genetic testing on the DNA in the 1 or 2 cells that are removed, and you'll know the genetic makeup of that embryo prior to its implantation. Pre-implantation genetic diagnosis, or PGD. So that's a technique that was developed really in the 1990s to try to help people who knew they were at risk of passing on a genetic disease avoid that by making embryos outside of the body in vitro, testing them using that technology, and then only implanting those that were not diseased. Cystic fibrosis was kind of the example case. So actually, this goes back to the Minnesota days, and President Sullivan will, I think, remember this story. This is a story about a family named Jack and Lisa Nash. The little girl in the middle of the picture is named Molly Nash, and the little boy on her lap is named Adam. It's the first savior-sibling case that happened in the world, happened at the University of Minnesota. It's a story about a couple, that the 2 parents there, who didn't know that they were at risk of passing on a genetic disease called Fanconi anemia in this case. So they both were carriers, unaffected. Their first child, Molly, was born affected by this disease that causes, among other things, you can see she has kind of misshapen hands and wrists. They lack thumbs. They have some fused joints. Those of you who are physicians in the audience probably can tell me much more about the syndrome cause. But the important thing for the story is that they get leukemia, depending on the mutation, by the time they're 6 or 7 years old. And in this case, the parents wanted to cure their daughter, but at the same time, they wanted to make sure they wouldn't have any more affected children. Children were affected by Fanconi anemia. So they hit upon the idea that they could make embryos outside of the body using in vitro fertilization, use this technique to determine whether the embryo had Fanconi anemia like Molly, one step, and those that were not affected, they would test again to see whether there'd be a match, a human lymphocyte antigen, an HLA match to Molly, and then they could use the cord blood from the resulting baby as a transplant to treat her leukemia. Okay? It's a much longer and dramatic story, which I could tell you if I were only talking about this. But out of that effort, made an embryo, tested it twice, right? So once to avoid disease, which everybody thought was an ethically acceptable thing to do. But then the second stage turned out to be very problematic from the perspective of the laboratories that were engaging in this service. So they were happy to test to avoid disease mutation. They weren't so happy to test for HLA compatibility with Molly. They got only one laboratory in the US that was willing to do both of those things, which happened to be in Chicago. Family lived and still lives in Denver, Colorado. So there was all sorts of flying around and taking back very small pipettes with a few cells back to laboratories in Chicago, phoning back to Denver. This is the embryo, that's the right combination. 2 embryos out of 17 had the right combination of Fanconi negative and HLA matched to Molly. Only one of them resulted in a successful pregnancy that is that little boy, who they named Adam. Yeah, so straight out of Genesis. You may remember that in the biblical story of Genesis, a rib from Adam was taken to create Eve, and that's how the parents thought about the fact that a part of Adam, his cord blood in this case, was used to save his sister Molly. So what's sort of novel about this? Well, first let me show you fast forward. So that first picture, the AV guy, by default, that was me. The first picture is taken before Molly went back into the hospital for her last round of chemotherapy prior to the transplant with the cord blood. It was taken in the Mall of America in Minnesota, where those days I think it was called Camp Snoopy. Inside, the footprint of what had been a football stadium is now a very large mall. For those of you who haven't visited, there's an amusement park. And they asked her what she wanted to do before she was going to go back in the hospital. I want to go to Camp Snoopy. So that's the merry-go-round in front of Camp Snoopy. So fast forward 6 or so years, the photo on the upper right there is from the Denver monthly magazine called 5280, The Miracle of Molly. So they're both older and healthy. They went back to live happily ever after in Denver. And then this book was written, many of you may know this book, a novel, which is about sort of this story, but 2 daughters, right? Not a daughter and a son. And Jodi Picoult came and spoke to the Nashes, actually spoke to me. I was involved in this case, spoke to John Wagner, who was the physician caring for Molly, and interviewed us all about this heroic story that she was going to write, which turns out not to be so heroic in the novel form. It was a pretty popular book. It was made into a movie that was not terribly good, but it was a sort of popularization of this story, sort of how it could go off the rails, right? And the purpose of my telling you all this is to say there were no relevant policies to figure out what to do in a case like this, which turned out fine, but could have turned out not so fine. And still, frankly, people could do something similar with much less responsible outcomes. So why is that? So we have a ban in this country on federal funding for any research that harms or destroys a human embryo. That dates back to the Reagan administration. For those of you who don't remember what was happening in 1981, first Reagan administration, when there was a view that in the aftermath of Roe v. Wade and abortion policy, that the federal government would not have dirty hands and be involved in the destruction of human embryos with its federal dollars. So we've had a prohibition on the use of federal monies used in research that harms or destroys human embryos since that time, and it keeps getting put into the Budget Reconciliation Act each successive year. So it's just a feature of our federal policy. So you can have federal monies to perform so-called embryo research, but it comes with no oversight, no rules, because in this particular area, biomedical research, if you don't take federal money or federal money isn't invested in it, there aren't actual regulations. So there's no federal law, right, about what we can and can't do with human embryos. That would have to come from Congress, and the Congress hasn't been willing to act on that. And there isn't executive branch policy, say from the National Institutes of Health, because their hook is funding. So there's a sort of giant gap here. Second, the places and people who create embryos for the purpose of reproductive medicine, often there will be extras, and those are then available for potential use. It also turns out because the payment for those services are not covered by insurance companies, although that's changing and changed pretty dramatically under the Affordable Care Act, it's sort of up to the patients in conjunction with their providers to decide what's appropriate uses of these technologies. So the lack of insurers' oversight may be a good thing in some respect, but it means that there aren't people looking at and deciding what the relevant uses of these technologies might be. The folks who do reproductive medicine for a living compete with each other quite fiercely, both for patients and to do sort of the latest, greatest thing. And so that leads to a little bit of a Wild West mentality. This is part of the reality that led to the discussions and debates in this country around human embryonic stem cell research, which kind of settled down during the Obama years. And then lastly, in this particular story, nobody was responsible for the whole thing. So the embryos were made in Denver, their testing was performed in Chicago, and the cord blood was actually flown from Denver after Adam was born, flown to Minneapolis, where it was stored until the family could travel and Molly could be transplanted. So everybody sort of pointed to everybody else about, well, they did the testing, well, they made the embryos, well, they did the cord blood transplant. And so that led to a kind of perfect storm of lack of policy. So it was the ingenuity of the family that led to this. So very strong incentive on the part of the family to find a way to treat their very sick daughter, which laudable, and I'm sure many, if not all of us in their situation would have pursued any avenue. Turns out that Mrs. Nash is a critical care, pediatric critical care nurse, so very savvy, knows how to manage and navigate the healthcare system. And Jack Nash is in his family business, which owns a chain of hotels in Denver and surrounding areas, and so they had resources. In fact, they flew back and forth between the various places in their own plane. So they were able to navigate both financially and in terms of their wherewithal in a way that most other people would not likely. So they were highly incentivized, highly resourced, and a lot of insights. And so they were able to sort of find their way around the restrictions, and in this case, there were very few anyway. So ingenuity, blunting policy. The next version of this is about prohibitions being put in place in ways that lead to actually worse outcomes. So it's the sort of flip side of the coin of the story I just told you. So there were no policies in the Nash case, and they came to a good outcome in ways that might be problematic in other examples, but it worked out well for them. This is a case where there is a strong prohibition in this country, which I'll show you in a second, led to a very bad outcome. And this is a story about something called mitochondria replacement. It's going to be hard to tell you what this cartoon means, but I'll do my best. So that is a screenshot from an Institute of Medicine, now National Academy of Medicine report on something called mitochondria replacement. The important thing to understand is that that left side is 2 human eggs, one of which comes from a woman who carries a genetic mutation in her mitochondria that causes illness. And in some of these mitochondrial DNA diseases, they're really almost incompatible with life. They're very, very serious and very significant. The way human biology, mammalian biology works, the mitochondria all pass from mother to child, maternal inheritance only. And so if a woman knows that she's got mitochondrial DNA disease risk and that she'll pass that on, all of her offspring will be affected. There's no contribution from males. One of the additional examples about why males are increasingly less necessary evolutionarily. So the mitochondria are the batteries, the power packs of the cells, and there are mitochondria in sperm because they need to have their tails do their thing and swim. But as soon as a sperm fertilizes an egg, there are enzymes in that egg that degrade the mitochondria in the sperm. So making sure that there's only maternal passage of mitochondria. Interesting. I learned this biology because I chaired this committee. So the story is that there are women who have that disease risk. There's nothing that they can do and still have a genetically related child. Here's the sort of kicker. So these are people who feel very strongly that they want to have a child that's genetically related to them. One way to avoid this problem is to have an egg donor. So a woman who doesn't have mitochondrial DNA disease could donate her egg, have that fertilized by the woman's partner's sperm, and that woman could then carry the pregnancy. But for women and their partners who want to have genetically related children, biological connection to both parents, the only way around that is to actually get a donor egg and have those mitochondria replace the diseased mitochondria in your egg. Yeah, there's the, thank you. That means I said it in a way that you could understand it. It's very, not as complicated as it sounds to do, but you can effectively take 2 eggs, make 1 out of them, and then fertilize that with the sperm, and you get a new developing embryo. Too loud, too soft?
No. Trying to get your pointer.
Oh, it's okay. It's attached to this, but it's totally fine. I don't think I need a pointer to make it work, but thank you for trying. So this is a cartoon of how that would work. I'm sure your mind's now sort of, what does that mean exactly? And so you can see that the nucleus in that top picture is removed, right, and put into the nucleus of the, is put into the egg cytoplasm of the donor. So you've got the nuclear DNA from the woman who's got the mitochondrial DNA risk, the cytoplasm of the donor woman, fertilized by the sperm of the partner. So you've got the contribution of 3 people, 2 women, 1 man, genetic contribution of 3 people. That's the novelty here. So unlike IVF, which was very controversial at the time it was started in 1978, was the first so-called test tube baby born, right? That was helping what would otherwise happen in nature, but outside the body. 1 egg, 1 sperm, and you get fertilization and hopefully an embryo that will result in a baby. This can't happen in nature, right? And so the question is, from the Food and Drug Administration of the United States, should this be permitted to go forward as a matter of ethics? And if so, under what kind of controlled conditions? So I chaired a committee that was asked that question. We actually went through a very long, year-long process, multiple meetings, heard from women who suffered from this disease risk, very compelling kind of arguments about why they wanted to do it, heard from the biologists and the reproductive medicine folks about how they might do it. So we proposed that it could happen, go forward under very controlled circumstances. The most controversial recommendation of that was that the way to make sure you weren't doing something that was really potentially problematic and passing the mitochondria on to successive generations was to make sure you only had male children. So only implant male embryos made this way, sex selection effectively. But as a way of avoiding the potential problem of the passage of whatever this combination might be to future generations. Now remember what I said in that earlier slide. I showed you the highlighted language about the NIH will not consider modifications that cause germline modification. So one question is whether this counts as germline modification. Some are shaking their heads no. This is the time when I would actually ask somebody to defend why they think that. So it turns out that this committee said it's a heritable genetic change, at least if it's passed from mother to daughter. Is it a germline change? It depends on how you understand what that means. So the UK went through a parallel process and said it was not germline modification because they understood in their policy that germline modification only applied to nuclear DNA. So yes, it's a heritable genetic change, but not a germline change. So it kind of depends on how that definition would be understood. The folks at the NIH who are charged with applying the policy that I had highlighted in yellow in the earlier slide said, we absolutely think that it would apply to this, so that they would not allow MRT to go forward. The FDA actually was ready to enact the recommendations of this report, and then Congress intervened, and in the budget reconciliation process in late 2015 said the FDA may not receive license applications for anything that creates a heritable genetic change in a human being. And if they did that, they would lose their funding. So it's sort of very significant restriction. All right, so it's prohibited. This is prohibited in the United States as of December of 2015. The FDA was considering implementing recommendations, but they could not based on that congressional decision. So here's what happens. Prohibition in the United States, September 27, 2016, so just over a year ago, there's a report of the world's first baby born with this technique. And in the shorthand, in the headline writer world, it's called three-parent babies. I don't think that's correct, and in fact, the report that we wrote said they're not three parents, but that's the easiest way for headlines to get written, and it captures what that cartoon showed you. So how did that happen? So you can read that yourself. The most important part of it is that the person who carried this out is a US-based reproductive medicine doc who runs a clinic in New York, who opened a satellite clinic in Guadalajara, Mexico. And he and his colleagues went to Guadalajara, had patient and her husband from Jordan, as in the country, Amman, Jordan, who came to Guadalajara where this technique was performed, the embryo implanted, and a baby was born. Now, what's interesting about that, as you can see, neither method has been approved in the US. There's two ways to go about the cartoon that I showed you. So Dr. Zhang went to Mexico instead, where he says, quote, there are no rules. So I went there because it was prohibited in the US that there are no rules in Mexico, which turns out not to be quite right, but that's why he went there. He's adamant that he made the right choice. So that case was about a woman who had a very significant mitochondrial DNA disease risk. And so you would say, well, at least it was to make sure that the child that would be born would be healthy. The concern about the way our regulations in the US work is once it's approved, there will be a very strong incentive to use this technique or any technique that gets created, so-called off-label. So while it would be first licensed for women who have very significant risk of passing on mitochondrial DNA disease, it turns out that there's a thought that women of advanced maternal age, whose eggs seem to be tired, the mitochondria are not producing a sufficient amount of energy, that this would be a way to get a young woman's mitochondria into an old woman's eggs, and you can have babies that way. And so it's been reported just a few months after the report that I showed you. This is from October the 10th, 2016. The three-parent baby method has already been used for infertility, this time in Kiev. Okay? So the point being that certainly would not be permitted in the United States either, and so different group, not the John Zhang group, but a different group using this technique, again, outside of a country where there were restrictions. All right. It turns out that there's another way forward, and this is where we can sort of point to our friends on the other side of the Atlantic for some inspiration. In the UK, they have a very strict control over when you can make or use any human embryo, something called, believe it or not, the Human Fertilization and Embryology Authority, the HFEA, which sounds a little Orwellian, but it's the centrally controlled office, the office that centrally controls the making and use of any human embryo. And they have actually gone through a very significant process to allow the licensing of a clinic and one patient to go through mitochondria replacement, one at a time. Right? And they've got a pathway that actually Parliament had to vote on whether it was something that should be permitted, given the policy changes that needed to happen for it to do so. They did, they approved it. There's a path forward. So tight control actually offers a much clearer path for innovation than a prohibition in our country would allow, which is sort of counterintuitive to the way people think about the usefulness or non-usefulness of restrictions. All right, so I'm going to now switch gears and for the remaining few minutes here, talk about sort of the most recent science. And I'm leading up to the conclusion here that we need at least a new approach, if not new rules. So to echo Asilomar, which to remind you was 1975, Nature, very prominent science journal, editorialized in October of 2015 that scientist-led conferences are no longer the best way to resolve debates on controversial research. So then you might ask, well, what is? That's where it gets a little more sticky. So what's different about science in the 21st century? So if we talk about almost 40 years since Asilomar, what's different about now we're heading into the sort of early mid part of the 21st century as compared to the latter part of the 20th century? So a very few people were able to do recombinant DNA work in 1975, and those that could really were in the US and the UK. Not true today. So science, for good or for ill, is far more democratic, and it's no longer one country that is sort of the leader in an area of science. And as I was talking to some of your medical school colleagues today during some of our meetings, it's much less technically sophisticated work than it used to be. You don't need fancy laboratories or fancy equipment, and with less expertise being required, that means many more people are going to be using these tools, which makes it much harder. That means it's much less useful to even try to self-police, if that's the right way to even think about it. There are very few mechanisms for such a dispersed and distributed science to be policed by science itself. And there isn't, and I would argue can't be, concentrations of expertise and leadership in ways that would even make that possible. So that's a big challenge for how we're thinking about issues today. So the tools of the moment, and that's part of, I think, the take-home here, is that we've been here before. They're just different versions of the discussion, and these may be much more widely applicable, right, and much more precise and safe. But we've been through this sort of new tools for doing things in our genetic lives that we couldn't before. So this is from a National Academy of Sciences International Committee report, which was issued actually on Valentine's Day of 2017, that tried in part to answer the question about what might be done about international governance of the use of these new gene editing tools in humans. So there are many applications of so-called CRISPR or Cas9. There are other versions of gene editing tools, but CRISPR is the one people have heard about in plants, in animals, in humans, right? Anything with DNA can be edited by these tools. This particular committee was asked to opine about what can be done about human genome editing. And so among the things that this committee recommended, and I was a member of this committee, I was not its chair, was to identify 7 principles that any country that was hoping to take on governance of these tools really ought to, not might, apply. And that blue box on the right says exactly what I just did. Any nation considering governance of human genome editing really should incorporate these principles and the responsibilities that flow from them. Okay, now these are pretty mom and apple pie, frankly, right? No one would argue with these. It's all in the sort of what does that look like when you actually start to try to do governance. And remember what I said about germline modification, because that's going to come back to us yet again. So what are the challenges? Well, principles, and that's what these are: promote well-being, be transparent, use due care, which really means be cautious, carry out science in a responsible way, be respectful for persons and their decisions about what they want to do in their reproductive lives, so on and so forth. They're very high-level principles, and they're not the same as governance. So governance is what we take those principles and say you can or can't do X or Y, and that's a very different thing. And that requires, however you do it, privileging some principles over others, because there'll inevitably be some kind of conflict when you can't be cautious and respect individuals' rights to pursue their reproductive future as they see fit, right? Those two things don't necessarily live well together. And the answer to how governance shakes out in those contexts is going to be based on societal and cultural differences. The example that's easiest to point to is the consideration of the use of human embryos outside the body in our country, and other European countries sort of follow suit in terms of how restrictive we are, versus places like China. A very different cultural attitude about human embryos outside the body, just different. It's not an argument about who's right. And so there will be a different answer to the governance question based on how you as a society think about the answer to the question of what is the status of a human embryo outside of the human body. And so we're going to find, even with shared principles, very different answers to the governance question. It will be not only a definitional set of issues, but those that we think of as what counts as a physical or a cultural harm. So that is how we think about harms to society, how we think about the respect we afford or don't to human embryo. And those differences will yield differences in policy. And then the last point on this particular part of my talk is that, as the example of MRT in Mexico shows, there will be medical tourism, whether that means tourism on the part of the investigators/care providers who are going to places where there aren't rules and people following them there, or people going to places where they can obtain services that aren't available in the countries in which they otherwise live. That happens now anyway, not just in reproductive medicine, but in other areas of medicine as well. Transplant tourism is the example. So one of the very strong points of emphasis in the discussion about how to move forward in this area on the part of this international committee was this, that there needs to be public engagement. So we do a not very good job of that in this country. The UK does actually quite a good job on engaging the public when it comes to controversial biomedical research areas. Either way, in the context of this discussion, the Chinese member of the committee on which I served raised his hand and said, we can't engage with 2 billion people. Right? It isn't possible. What does that even look like? What is representation of the public? If we wanted to, what would it look like in a country of the size of China? So this is easy to say, very difficult to do. All right, so the last bit here is about where we are in the science. So this is very, very recent reportage, and that's from the issue of Science in July of this year, the end of July, the 27th, which reported on the first US team to successfully edit in human embryos, edit out a disease-causing mutation. It was performed in Portland at the Oregon Health and Science University. There's been some debate about whether what they found in their results was explainable by molecular biology the way they have, but that aside, an important step forward in that two things, really three, but two things that were on the path to being answered more quickly than anybody thought. So before you start to think about using these techniques in humans, you would need them to be safe, right? And effective, that work the way you expect. And so one way to understand safety is that the gene editing that you do actually happens where you want and the way you want. Off-target effects is the science term that people use. And the second is that you get the change that you intend in all of the cells of the resulting organism, because if that doesn't happen, you haven't achieved your goal. And this paper seemed to indicate that both of those things were somewhat under control. You didn't have off-target effects, and you didn't have what's called mosaicism, where you've got the same edit in all of the cells of the developing organism. Now, this was done by doing the edit at the moment of fertilization, so that helps blunt the concern about mosaicism because you're starting from a single cell. That said, it seemed to begin to answer some of those questions. So if you've got safety somewhat under control, obviously much more science has to happen before we would say we're ready to do this in humans, and you've reduced uncertainty, which is part of safety, of course, we would say, well, what's the barrier to doing modifications that create heritable genetic change, that actually affect the germline? What's the ethics concern? Which, believe it or not, we had, as a scientific community, a bioethics community, hadn't really answered that question. It was always, it's not safe, it's not ready, too uncertain. But that doesn't answer the question about why it's ethically wrong to make a modification that will be passed on to future generations. And so this is starting to force that discussion in a much more significant way. So what comes next? So the committee that I mentioned, the International Consensus Committee, which issued its report in February, was not the end of this discussion. There had been a summit held in Washington in December of 2015, which started that discussion. The Consensus Committee issued its report in February of 2017. There will now be another summit held in either Shanghai or Beijing sometime in 2018 to assess where the science has come since the last summit and since the report I mentioned was issued. Do some, come to some consensus maybe, issue a statement in answer to that question, and then 18 months from now, from when that one is held in China, another one in the UK, as kind of movable feast of discussion around gene editing and the policy and appropriate behavior. Those principles that I showed you have a little bit of meat on the bones in the report that I mentioned, having been the source of those principles, but they really aren't fleshed out sufficiently. So if we really are serious about international norms around principles, there needs to be some conceptual and foundational work done. That's stuff that I actually like to do and I'm involved with. And so with that, there will be work towards something like international norms based on principles like those and others. Much more experience will come from research, and maybe at some point the first clinical attempts. Now, it makes it really hard to think about this. So just like with MRT, among the challenges are things like informed consent. So when we do research on people for the first time, we call that first in human research. We want to make sure those individuals give us consent and they understand what it is that's happening for this very first time in humans. What we're talking about is creating a human for the first time using this technique. You can't get consent from the person who will be created. So it kind of undermines the whole notion of consent. How do we think about that? What do we do? Parents can give consent, but it's not the same thing in the context of what we're talking about. So how would we imagine that to work in a clinical research and maybe eventually clinical application context? And any of that would need to happen in the context of robust engagement of the public about when it's societally acceptable to go forward. And then as that happens, you get nation state, that's not state like Vermont versus Maryland, nation state level policy development, which would then bring oversight and enforcement, and we hope people wouldn't sort of venue shop for what the best place to do this science might be. This is my last slide, and then I'll stop, which is, again, an editorial from Nature, which was just published in September of this year, just a week and a half ago, which already, I mean, the science has moved incredibly rapidly where we're already ready to take stock of the research ethics of the use of gene editing tools in embryos. And the important take-home is on this little pull quote that I have, right? So the particular requirements of studies will differ, but a strong framework for assessing them as early as possible seem the best way to ensure we do this in a responsible way. That's where we are now. That's pretty clear, and I've sort of led to this conclusion myself, but the question is in the doing. We don't have good examples or good tools for how we do this on an international basis, but we really, really need to make sure we try to figure it out as soon as possible. So with that, I'm going to stop, have some time for your questions or comments, and I appreciate your being so attentive. Thanks.
You mentioned in one of the slides about these scientific consensus meetings that maybe that's not the way to go, which sounds like what you ended with is we're going to have this movable feast of scientific meetings trying to come to some consensus, as opposed to what I assume you were talking about, and I think you mentioned it, the marketplace, which is this is going to be hammered out by who makes the money, who's going to figure out who's going to become a center of this, and somebody's going to say, I don't care what a scientific consensus group says, I'm going forward.
Yeah, and I guess the question is who in that sense is the someone, right? And among the attempts of this international movable feast is to bring all the relevant players kind of under the tent in a way that won't happen. Now, in some countries, we have this problem of the John Zhangs going to places where they can set up satellites. In other countries, there's a much stronger control over what the scientific community does or doesn't do. And so I think the argument is if we all talk about this together in a way that we are all in some kind of agreement that there'll be less chance of that. It's impossible to prevent altogether. Among the interesting sort of politics of this is the UK is really interested and engaged by the idea that they can be a leader in this area. And so they're actually pushing hard on their policy machinery to allow that to happen in a way that they can point to the fact that they were first, whatever that thing might be, first in this, first in that, in a controlled policy environment. And I think that's a big motivator for them. It's kind of competitive advantage. And the other thing, which I didn't talk at all about, but is actually important to this too, is intellectual property, to the extent that it exists in any of these areas. There's a huge fight, as I'm sure you all know, in the CRISPR world about who, whether the Berkeley group or the Harvard MIT Broad group are the first to claim intellectual property rights on the discovery and therefore licensing of CRISPR. So I think it's complicated. It's really complicated. But I think it's not enough to say, it's just complicated and somebody's going to be first and we're going to have to live that way. I think that the scientific leadership of the world's academies, at least if that counts as leadership, are really wanting to figure out how to do this the right way. One last thing is that there's sort of an odd place for this to have a little bit of bite, which is in the publication in international biomedical journals. So when you submit to publish in any of the journals that have signed on to I always get the acronym wrong, but the editors of international biomedical journals have a set of requirements, which include, authorship, and you check those boxes when you submit to places to publish, but they also require that you follow human subjects guidelines, and they could require something related to what you do with human embryos. They don't at the moment, but that would be a way that's a kind of cross-border approach to some kind of basic flora behavior in science in this area. I don't know whether they're talking, I've said this a bunch of times to a bunch of people and everybody sort of nods, but I don't know that they've actually taken this on as something that they want to be responsible for. Anyone else? There's a couple hands.
So that was fascinating talk in a lot of ways, and so there's many undercurrents to that talk. One of them is this sort of attitude that genetics is different than other human endeavors, and sort of the genetic exceptionalism argument, like the American exceptionalism argument. That's another topic. So this is confronting that full force, right? There's a lot of human activities that have created situations where we actually do pass along problems to our next generations. I mean, famine and chemicals and genetics just seems to be another extension of that, but it's treated differently than that. Is that true around the world? Do people see the genetic aspect of this as different from a lot of other human endeavors? And is that affecting how this is going forward?
Yeah, it's a really great question. Deborah Lynn and I were having this conversation earlier today, this exact conversation. And I'm not a big believer in genetic exceptionalism. I think we've overemphasized that. One thing I didn't say in my talk was that the National Academy's International Consensus Committee actually said it would be acceptable to go forward and modify human embryos to prevent disease, so that would create germline modification, if a very long list of criteria could be met. But that's effectively saying that this bright line prohibition that had been in place since the 70s really didn't seem to have reason to continue, right? And so it's a way of saying this notion of genetic exceptionalism doesn't really need to be thought about that way any longer. Now, there's a big debate in the ethics and genetics community about that. What's special about genetics and genomics? And there are some things that are different, right? When we test you, we also are finding out information about your ancestors and about your children. And that's different than lots of other things we do in medicine. So there are things we have to take account of. But as we get into actual alteration of genetic makeup, should we think about it any differently than we do other kinds of alteration, physical alterations? I think it's a very fair question. I'm not answering it, but I'm with you that we're heading to a time when we ought to be thinking about it more like other areas of medicine and less like something special and different. So that's as close to an answer as I'll give you in 30 seconds. I think your president also is raising his hand. At some point, you probably should give him a chance to talk.
So how big of an issue really is it to get consent from the baby you're creating?
No, you can't.
No, I know you can't. And we do surgeries on
yeah,
babies
right.
in utero. I mean, we do tons of things for not yet out of the womb babies. The Adam that was created, there was no consent for him to be created, which is part of the point of Jodi Picoult's book. So how much of an issue is that really?
I think it's an issue in that this is in those other examples, we make babies by IVF and have for a long time, millions and millions of them. So we don't need to think of it as a sort of super novel way of being brought into the world. It's sort of like the first cases of fetal surgery, right? And so you say, well, somebody has to go first. How do we know when it's time? What level of information and certainty do we need from animal models, whatever things you would put into that? And you want to do what's in the best interest of that child. It's a little bit of a harder case when the thing you're doing is actually what brings somebody into existence, right? At least in a fetal surgery case, there's something that needs to be addressed in that developing fetus. So this is the first time we've ever mixed two women's genetic contribution, fertilize that with a sperm, and put that into a woman's uterus to gestate. How do we know when it's appropriate to do that? Now, the committee that I chaired actually listed a very long set of criteria about how much animal information you would need to have and how controlled you would need to do it, and to make sure that there wasn't any untoward effect in passage of maternal mitochondria, restrict to male embryos. We thought that all through and said, if all these things were met, then you should go forward with a whole lot of follow-up. But you have to eventually jump off the cliff for the first time, right? And that's your point. And it would always be without consent of the child that we brought into the world that way, absolutely. The problem is we have relied so much on the consent of the individual to do things to people that were not in their best interests. In the research context, that's the other thing to be really clear about, that we can't rely on that in these contexts. So we need some other way to feel like we have satisfied the things we thought were important for the reasons of consent, right? What was consent doing in those other contexts, and what can we replace that with in a context where we can't get consent? It's really hard. And we have to rely on people's being, interested in the best interest of their offspring. But of course, they can't control that either. And part of the challenge is the women who will line up to have this are desperate to go through something that will prevent them from having an affected child. So they're probably not in the best position to be making a clear-headed decision either, right? It's sort of, how do we do this in a way that makes the most sense of of the work we thought consent was doing for individuals? Saying the same thing 3 different ways. Tom.
Jeff, you emphasized in your remarks a couple times the importance of transparency and engaging the public in sharing their viewpoint as you sit and others on scientific and medical advisory panels. And I know this is an individual, country by country, but how much deference or weight do you give the public testimony one way or the other, given how difficult some of these political conversations are in our country, and I suppose others as well? You have to dutifully sit there and listen and take it seriously, but they're often not expert opinions, but public reactions or emotions, and how do you weigh
Yeah.
the deference point?
I think it's a really good point and really good question. I think that it's not majority rule, right? It's not a democratic process. But if these are techniques and technologies that have societal implications, society has a right to weigh in, right? And the question is how much weight to give that it's really important. Turns out we don't even do that sort of first part terribly well in this country. So in the UK and actually across Europe, they actually poll the population at frequent intervals about all sorts of things to sort of take the temperature of the public. And in the case of MRT, they actually spend many millions of pounds going all over the country talking about what they're proposing to do and trying to seek public input about what they thought about it. Was it something that was appropriate to allow to go forward? Now, in that case, it was pretty clear, and I've read a lot of the work about this, that the public was overwhelmingly supportive of allowing it to go forward in a controlled way. So I think in this country there would be much more diverse opinion, and that's part of the challenge. And so the best we seem able to do is, as you put it before, is public comment. But that's not the same as sort of letting the sort of public weigh in about how they understand the societal implications of what it is that's being proposed. And so I've never felt great about sitting in conference rooms in Washington, inviting people, saying it's time for public comment, and whomever shows up, gets to say their piece, and we call that engagement. It's not engagement. And so there are people who do this as their scholarly work. How do we better engage the public? And it's different than what science museums do, which is science education and science communication, which is of course important too. But that's different than engagement of the public in issues that have societal implications around science. So I don't know the right way to do it, but I would say that we're not anywhere close to answering that in a way that I feel like we've really engaged the public in a way that I feel like I can say the public understands, is engaged by this, and said this is appropriate to go forward. Not exactly an answer to your question. At the end of the day, our science policy is made by experts. Yeah. And that's the system that we have. It's served us relatively well. But I don't know that that means we know what the public thinks about the things that are being proposed. And we work at universities where we have a snapshot of one kind of public, but not all the public.
All right.
We're done. Okay.
The conversation doesn't have to be over. I would just ask that we're going to move it down the hall to the Hale Gallery where we will have a reception. And I'd like to thank you.
Thank you. Lovely. This looks like stuff that Orly would love very much.